Hello and welcome to Mr. Taufi Maths and Accounts channel. I'm so happy to be here today. In today's video, we will be going through questions on estimations and approximation from the Lagos State BECE Maths. Okay, so if you haven't seen the previous videos on the theme, numbers and numeration, the syllabus is basically divided into 4 parts. So this particular topic is from the numbers and numeration section of the syllabus. So we have done so many topics, from percentages to fractions to commercial arithmetic to directed numbers and so on and so forth. So make sure you check them out, as these topics are very crucial to your overall performance in the BECE mathematics. Without wasting further time, we're going to do some questions on approximation and estimation today. All right, so let's get it started. The first question says that express 2,966,739 to the nearest thousand. So anytime you're giving a number to round to the nearest thousand, nearest hundred, nearest tens, nearest unit, and so on and so forth, all you have to do is, so let's rewrite the number. So we are told to add to the nearest thousand. So all you have to do is to check the units, the place value. So the place value. So this is the units, this is the tens, this is the hundred, and this is the what? Thousand. So our approximation is going to stop on this number, right? So we're going to have to stop there. Now, the final thing is that you now look at the number just before it, the number just before 6, okay? The number just before 6, which is 7, which is 100 digits. So you look at it, is it 5 or more? Is it a number from 5 or more? If it's a number from 5 or more, then you change it to 1 and you add that 1 to 6 to make it 7. Okay, but if the number is 4 or less, then you just leave the number in that particular degree you're rounding to. So in this case, we are rounding to the nearest thousand. We have to stop at 6. The number just before it is 7, so we're going to round up, meaning you're going to add 1 to 6. So therefore our answer will be 2. So the first 3 numbers, this one will remain unchanged, so that will be 2, 9, 6. Then because we're stopping exactly on this, and the number that comes after it is 7, then we're going to add 1 to 6 to make it 7. Then what happens to the remaining digits? These 3 other digits are just going to change to zeros. So 0, 0, 0. So our answer is 2,967,000. Option C. Okay, that was very quick. Number 2, round the decimal number. The next question says round the decimal number 45.678 to 2 decimal places. So 2 decimal places just means that how many digits we want after the decimal point. Okay, so 2 decimal places means we want 2 digits after the decimal point. So if you look at, this is the decimal point, this is the first digit after the decimal point, this is the second digit after the decimal point. So that means our rounding is going to stop exactly at 7. So look at the number that comes before 7, which is 8. This is the number that is up to 5 or more, right? So is 8. 8 is more than 5. What do? That means you're going to have to round up. Basically, it means you add 1 to 7. So eventually, our answer becomes 45.6 instead of 7, 8. Now, what's going to happen to this? This is going to become 0 because it's going to become 0. This 8 is going to become 0. But at the same time, this is decimal points. We only want 2 digits after the decimal point. So you don't have to write your 0 anymore. So we leave it like this. This is our final answer, 2 decimal places. So 45.68. So assuming the question was to 1 decimal place, then our answer would have been, that means we just only need to stop at what? We stop at 1 decimal place, means 1 digit after the decimal point. So we stop here, and then the number just before that is 7, so we add 1. So 1 decimal place, our answer would have been 45.7 if it was 1 decimal place. Okay, so keep that in mind. Very simple, excuse me. So very simple. And lastly, significant figures. So this one tends to be the most confusing for students, and it's very simple. So when we talk about significant figures, we're basically saying that from the left to right, okay, from the left to right, what is your first non-zero digit? From left to right, your first non-zero digit is your first significant figure. So 0.03482. These digits, this 0 here is not significant. This 0 is not significant. This is not significant because significant figures start from the first non-zero digits from left to right, okay? The first non-zero, and our first non-zero digit is 3. So that means that 3 that is our what? The first significant figure, second significant figure, okay? Third significant, so excuse me, this is 1 significant figure, 2 significant figure. I think I just need to write this number, so I need to space them out better. So 0.0348 and 2. Yes, this is better. So this is not significant. We're not going to write any significant because we are looking for the first non-zero digit from the left to right. So this is 0, this is 0. So the first non-zero digit is 3. So we're going to use that. So this is going to be our first significant figure, second significant figure, third significant figure, the fourth significant figure. So, so two significant figure, that means we're going to stop where? We're going to stop here. As you can see, we have our, this is the second significant figure, which means two significant figures. So we stop there. Check the number just before it. The number just before it is 8, and 8 is 5, is more than 5. Is up to 5 and even more than 5. It's greater than or equal to 5. It's greater than 5, basically. So as long as the number is from 5 upward, then you're going to add 1 to the previous number. Okay, so our answer becomes 0.035. Then 0, 0, right? This remains to become 0. Are we supposed to write these two zeros? No, because zeros, if you are looking at significant figures, the zeros are the end of your decimal point. So if you have a decimal number, if you have a decimal point, any zero that comes after numbers in decimal points are significant. So this is significant, right? So you don't need to write them. You don't need to write them. So this is just your answer. Are we together? This is just the answer. So our answer is B. And that's something about significant figures. So you need to be very careful. So that question now, this is what? This is two significant figures. Assuming we wanted to get three significant figures, it will have been 0.0348, right? And then if we wanted to get four significant figures, it will have been what? 0.03482. Are we together? So this is 3. This is 4 significant figures. If we wanted to get one significant figure, it will have just been 0.031 SF. Okay? Okay. So, but in significant figures, any zero, so if I have 0.00120, then this zero is significant. So this number, as you can see, this number is to 3 significant figures. Also, if I have 0.0101, even the 0 in the middle is also what? Is also significant. So it's important to know all these basic rules of significant figures. All right, finally, this question here says express 0.00034522 significant figure. Our first significant figure is 3. Our second significant figure is 4. And that's why we need to stop. So the number that comes right before 4 is 5. So it's up to 5. So we add 1 to 4, basically. We add 1 to 4. So our answer becomes 0.00035. That's your answer to two significant figures. As simple as that. And final question: if a school budget of 1,245,000, okay, if that's a school budget, and is split equally among 100 departments, find exact amount per department and round your answer to 2 decimal places. Your final answer to 2 decimal places. So we have 1,245,600 to be shared equally among 100 departments. So you have to divide. So we divide. This 2 0 can take out these 2 zeros, and then we're going to have 1, 2, 4, 5, 6. So it says to 2 decimal places. I really don't see why we need 2 decimal places, but if that's the case, so this is our answer. You just put a point here and just put 0 and 0. Okay, so this is your answer to 2 decimal places. 2 decimal places. All right, and that is all for this particular topic. Very straight to the point and easy. So this is your turn. Do the questions, and then let me know in the comments. Of course, as usual, the first 5 people to submit are going to get their question marked by me, by Mr. Taufik, and make sure you're among those first set of students to submit. So these are the questions. Let me make it a little clearer so that I can see them all at once. So solve them and I'm expecting your answer. I think one final thing I'd like to mention with regards to significant figures is that if you have a whole number, say for example, I have 250,000. How many significant figure is this? So there are quite a number of arguments, but we can call this 2 significant figures because these two numbers are significant, but the numbers afterwards are not they're not significant. So we call these 2 significant figures. So say for example, I have 2, 4, 6, 7, 8, 9, and I was told to write this as 2 significant figures. What will be my answer? My answer will be 2. So this is the first significant figure, second significant figures. So my answer will be 2. This one I'm going to stop my rounding. I'm going to stop there, and then the digit right after is up to 5 or more. I'm going to add 1 to that, so it becomes 2, 5. And every other number here just becomes 0. Right? So 250,000. So that's how to deal with all numbers. For all numbers, you retain the zeros afterwards, but for decimals, you don't retain the zeros afterwards when it comes to significant figures. Okay. All right. Bye for now, and I'll see you in the next video. Keep solving. I wish you excellence in your exams. Bye.